On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, this is another example of the volume of a box dealing with optimization, and we have a packaging company again, very similar to example 1. They want to make a rectangular box such that the sum of the length, width, and height will equal 64 inches, very similar. However, if the length of the base of the box is 3 times as long as the width, what is the maximum volume of this box? So we have a length, a width, and a height, and we want the sum of these three numbers to be equal to 64 inches according to the first sentence in this problem. Now, the length of the base of the box is 3 times as long as the width. Therefore, the length is 3 times as long as the width. This can be very helpful because now we've just taken 3 variables, length, width, and height, and we've at least got it down to 2 variables, a width and a height. We have that because I'm going to replace this length with the 3 times the width that we see right here, plus the width plus the height is equal to 64. Combining like terms, we have 4W plus H is equal to 64. This is going to be helpful in a moment. Now we're trying to maximize the volume of the box. The volume of a box is length times width times height. I'm actually going to change that color there, and now volume is equal to the length. We said the length was 3 times the width, so I'm going to replace that 3W for that L there, times the width times the height. Now let's go back to this equation here and let's get H in terms of W. Therefore, we'll have a volume formula with nothing but W's in it. To do that here, we can take H is equal to 64 minus 4W, getting H by itself there. Now we can take what H is equal to and we can substitute that into this H. Now we have a formula for volume that only has one variable, volume in terms of the width. Let's simplify this down. And all I've done here is taken 3W squared times 64, that's 192W squared. 3W squared times a negative 4W is negative 12W cubed. Since we're trying to maximize volume, this is the formula that we want to differentiate. Therefore, V prime is equal to the derivative of 192W squared is going to be 384W, just multiplying the 2 times the 192 there. Don't forget to subtract 1 from your exponent. And the derivative of negative 12W cubed is negative 36W squared. Same process for that right there. Now we have a quadratic here, and this quadratic does have a maximum because our squared term here, its leading coefficient is negative. So we have a parabola that opens down, which implies we have a maximum. Setting this derivative equal to 0, we can factor a 12W out of this. And dividing 384 by 12, we have 32. We don't need a W now. And minus 3W. Factoring the 12W out of 36W squared there. Setting each factor equal to 0, 12W is equal to 0. When W is equal to 0, that's not going to be helpful because then we wouldn't have a box. Setting 32 minus 3W equal to 0, we have negative 3W is equal to negative 32. And dividing by 3, we have W is equal to 32 over 3. This would simplify to somewhere around 10.6 repeated inches. Now I'm going to leave W as 32 over 3, therefore I'm not rounding before I get to my final answer. And back to the original problem, we're trying to find the maximum volume of the box. So we want to find the length times the width times the height. Well, recall, we got the length, the width, and the height. All of this stuff we got in terms of W. So we can take this 32 over 3, we can substitute that into W into these 3 spots up here, and that will give us the volume of the box. And as a matter of fact, the maximum volume of a box that has all these given conditions up here. And substituting 32 over 3 into W here, that's exactly what I've done in the calculator. 3 times W times 64 minus 4W, and that's exactly that formula right there. And if we round this off to the nearest cubic inch, we get 7,282 cubic inches. Simplifying that fraction, you have that right there. Just make sure you round or leave your answer as you are asked to do so in the problem. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.